Hi, everyone. Hang on. I'm unmuting everyone, and I want you to show your video. We have to test everyone. We have to test everyone's video, so please unmute your video. Because on Wednesday, everyone has to have video to take the test. Callie, I can't unmute you. Will you unmute yourself? I'm trying to make sure everyone has the right technology. Richard, can you unmute your video? I need to see that your video works. Please. Richard, I can't see you. And Tai Chi. Tai Chi, unmute your video. I cannot see you. And we have to make sure everybody has the right technology. Hang on, I'm just making sure everyone, all right. I'm admitting people one by one. And we need to make sure everyone's video works. So please unmute your video. Still unmuting some people, but I still can't see some people. Let's see. Good morning, everyone. Let's see how this works. Zachary and Conrad, I cannot see you. So please unmute your video. You should have a little, some video controls in the bottom of your window. Where's Conrad? Conrad, I can't see you. Zachary, I can't see you. And CJ, I can't see CJ either. You're showing me something that It's not going to work. I cannot see you, the person. So CJ, you need to fix your video so that I can see you. And Zachary, I still can't see you. At the bottom of your window should be a video control. Zachary, still waiting for you. And CJ, you guys can't take the test on Wednesday if you don't have video. All right, while they're figuring out their video, I want to ask everyone how they're doing. Start with, who am I looking at? Looks like he's asleep. Matthew, are you there? Can you hear me? Matthew, can you hear me?
Yes.
All right. How are you doing today?
Good.
Yeah? Any questions? Are you confused about anything?
Not so far.
Okay, good. Wow. All right. I'm still confused about a few things. All right. We're going to talk a little bit about what's going on. Then we're going to try to have class like normal. And then we're going to stop and talk about the test on Wednesday. Okay. Alex, how are you doing?
Doing good.
Yeah?
Yeah.
Any confusion, anxiety?
No, not really.
Good. All right, good. How about you, Emma?
I'm good.
You're okay?
Yeah.
All right. Any questions about what's going on?
No, I'm just trying to get used to this.
Yeah, well, yeah, you and me both. You guys are the guinea pigs, right? 8:30 Monday morning. We're probably the first class to meet. So far, it looks good to me. Tai Chi, how are you?
Hi, I'm doing good.
You doing okay? All
Yeah.
right. You got any questions?
Yeah, no.
Not right now?
Yeah.
Okay. All right. We'll have time for questions when we start talking about the test. See how I cannot hear you. You need to unmute your audio. There you go. Okay. How are you doing?
Yeah, I'm cool.
You doing okay? You all right?
Yeah, I'm right.
Okay. Do you have any?
I'm okay.
Do you have any questions right now?
No, yeah.
Okay. All right. Good. Richard, how about you?
I'm good.
You're good? Any
Good.
questions right now?
No.
Can you adjust there you go. So we need to see your face. I need to be able to see your face. So when you look down, so during the test, just so you know, if you guys are not looking at your paper, if it looks like you're not actually doing the test or you're doing something else, then it looks suspicious. So we got to make sure I can see everybody. I can kind of tell what you're doing. Also, if I get it up and running, we're going to be using a proctoring service, and the proctoring service automatically, I don't know how it works. It's artificially intelligent and it detects suspicious behavior. We'll talk about that later. All right. Hallie, how about you? How are you doing?
I'm good.
Yeah?
Mm-hmm.
Any questions for now?
No. I
No.
mean, everything's pretty straightforward for me.
All right. You sound good. You look good. All right. How about you, Nicholas? How are you doing?
Good.
Yeah?
Yeah.
Good. Any questions right now?
Not so far.
So far?
Nothing.
You might have some later. So we'll have time for questions. How about you, Stefan? Is it Stefan?
Stefan, yeah.
Stefan, how are you doing this morning?
I'm doing. No, I'm doing all right. I thought I saw. Did you say that the school was being shut down for the rest of the semester, or is it just some undetermined?
It is probably the rest of the semester, and it's not like it's shut down, but what I heard from my dean is no students are allowed on campus for the rest of the semester.
Okay.
So that includes student workers, I guess. So I guess you guys are being treated like, you know, you're the virus or something. And so
We are. It's true.
so we have to keep you away. But yeah, all the classes, every class is now online. And I don't know how that's going to work for the lab classes. I don't know what they're going to do. But initially it was just lecture classes that were going online, like this class. But now everybody has to go online. And so I don't know what's going to happen. But you guys can't go to campus. You can't go to the math lab, for example, or the library or the financial aid office. So we do have online tutoring. We do have NetTutor. And that used to be just after 5 on weeknights and all day on weekends, but now it's available to you guys 24/7. But I'm also available online. So for math help, you've got NetTutor and me, but you can't go to the math lab. And I don't know, I can't tell you much about your other classes. Some classes are having trouble going online today, and so they have until Wednesday to do it. Some instructors, you know, weren't set up for Canvas or anything, so they couldn't go online today. But we were already ready to go online, so we're okay. But yeah, you guys can't go to campus, I guess. That's what I heard. The official word from the district to you guys is basically all your classes are online. That's all, and no services are available to you. So basically, you shouldn't go to campus. There's nothing to go to campus for. Sorry. But I promise to keep you guys informed as much as possible on our Canvas site. I will make announcements as soon as I get information. I'll just keep it flowing. But you guys should really always be checking your email, check your Canvas messages, make sure you're getting my announcements as soon as they come in, because I might change something at the last minute, and you need to know what that is, and your other classes too. This is all going to be constant information flow. All right, let's get back. How about you, Caesar? How are you doing this morning? Caesar?
I'm good.
You're good? No questions right now?
Yeah.
Okay.
No, you kind of just answered some of them.
What?
I said you just answered some of them.
Okay. I'm going to let a couple more people in. So I'm going to unmute everyone, or try to. So it looks like Conrad, oh, there you go. Conrad, how are you doing this morning?
I'm doing pretty well, honestly. Just, I don't really have any questions. Just kind of interested to see how this midterm is going to go down. Is it?
Yeah, the midterm is what everyone's stressing about. I'm stressing about it too. We'll talk about that near the end of class.
You've answered a lot of my questions though, so I'm not.
Okay.
I'm chilling.
All right.
So.
CJ, I still can't see you. I need to see you live and in person, CJ. You have to turn your camera on. There you go. Wait, no, I still can't see you. CJ, please turn your camera on.
I don't have a camera right now.
All right, CJ, you probably aren't going to be taking the test because you're not set up. I'm going to send you some private messages and tell you what's going to happen to you if you can't. You're going to have to get a camera by Wednesday. That's just the bottom line. If you can't get a camera by Wednesday, there's a major problem with your test.
Yeah.
Looks like Zach Zachary, I still don't see you. Zachary, can you turn your camera on?
I could try to switch to my other computer.
Yeah, so everyone needs to have
Possible.
video. If you don't have video, by Wednesday, you gotta figure it out. You gotta get someplace where you have video to take the test. Because we're gonna use an online proctoring service that watches you. Let's see. Luis, how are you this morning?
No, fine. Thank you.
You're okay? You look,
Yeah.
you look wide awake. All right. So we're gonna try to have class as normal, and I will. I'm gonna mute you guys in a minute. We're gonna have class, and then we'll have time for questions. Let's see. I'm trying to unmute Kaleo. Kaleo, I cannot see you. Where did you go?
Test.
Are you there, Kaleo? There you, no, where are you? All right, Kaleo, you're gonna have to get your video and audio figured out by Wednesday, because you can't take the test without video and audio. Sorry. Natalie, where are you? I can't see you either. Natalie, same goes for you. All right, I'm gonna have to take names. All right. People that don't have video are gonna have to get some other technology. All right. All right, let's see, who else? Jeff, good morning. I don't see you either. Jeff, what's up?
Hello?
Good morning, I don't see you. What are you using right now? Why can't we see you? Jeff?
Webcam.
All right.
Hello?
Yeah, is that Jeff I'm hearing? Because I can't see you.
Are you hearing me?
I'm not sure who just said that because I can't.
Oh, that's me then. That's Jeff. Yeah.
I do not see you, Jeff. Do you have a camera?
Yeah, I have a webcam, but right now it's not set up. I'll have that tomorrow. I'll have it Wednesday.
You got to get it set up by Wednesday.
Yeah.
Cameron. Good morning, Cameron. Hang on, I'm trying. There you go. How are you, Cameron?
Good morning.
How you doing?
Tired.
Yeah, okay. I hear that. Welcome. We're going to get started in a minute. Let's see. Anyone else I have not said good morning to? I think I've said good morning to everyone. Okay. So what I'm going to do is I'm now going to mute you all. So do not try to turn back on your audio, because I'll control your audio and I'll call on people. But if you have a question or I'm going too fast or you want to stop me for some reason, you're going to have to raise your hand by using the chat feature. And you might, I can't see what you see, but you might see a reactions button. I don't know if you have that button. I tried to enable it, but I couldn't tell. So if there's a reactions button, you can raise your hand and then I can see your reactions, or I can see your hand. Okay, so I see a couple messages. I'm gonna put my message window over here. So CJ is working on getting a camera. Good. Okay, Jeff wrote to me. Good. And Kaleo, we got your message. So, okay. All right. So if you have a question, if you're trying to get my attention, send me a chat and hopefully I'll see it. I have another screen right here. Well, actually, let me move that so I can see it right there. Okay. And then I'm gonna, all right. So right now I should be sharing my screen. Can you guys all see the screen that says the date and it's day 1? I don't know what, hang on. I think, give me a thumbs up if you can see the screen that I'm sharing with you. Okay, good. All right, thank you. I'm gonna move that over there. All right, so we're gonna have class. We're gonna try to do it normally. I'm gonna lecture, you know what my slides look like. By the way, I am recording this. I forgot to mention that. If anyone objects to being recorded, you have to let me know. I'll send out a message, you can reply to that. And then I'll make sure that you are not, your voice is not in the recording. Let me resume share, hang on. There we go. So I'm recording this for you. Now, it doesn't mean I want you to skip class and watch the video later. I do take attendance and I do want you to be here, and it's best that you are here. And so you don't sort of get disconnected from the class. This is not one of those online classes where you just go watch a video and then go do the homework. So this is we're gonna try to make this as much like a face-to-face class as possible. So I want you to come to class. However, some people might have video problems or their internet might not be fast enough or whatever, and they can't participate fully. So the classes will be recorded, and I will embed those recordings on Canvas. But it might take a couple of days for me to get that up there, because it takes a while for the recordings to download automatically, and then for me to upload them to YouTube and then embed them in Canvas. So it does take a while. It might take a few days. So don't rely on just watching the videos, okay? All right, so, there's somebody trying to get in. Hang on. All right, let's see. Nobody, oh, there's one more person. All right, welcome. If you just walked in, I've got everybody on mute. If I can't see you, I am gonna send you a message because you have to figure out your video before Wednesday. Natalie, I can't see you. So you're gonna have to figure that out, and I can't hear you either. You don't seem to have any audio. All right, I will send you guys messages later. So let's start class and see how this works. So what we're gonna do today, so here's the agenda, check-ins. It looks like we already pretty much checked in. Some reminders and announcements. So you still have an exam on Wednesday, and I'm still figuring it out, but it will be on Canvas/Zoom. So my hope is to use this proctoring service called Proctorio, which relies on video. So you guys have to have your video figured out. You got to use a computer preferably, but you could use your phone, but you're going to have to stand it up and be able to write. So, because it's going to be a paper test, but you're going to have a certain amount of time to write down the questions, then write the exam, then scan the exam and upload it in Canvas. And so you got to get a scanning app, and I've told you how to do that. Some Android phones come with a scanning app. I can't tell you how to use it because I don't own one, but there's a lot of really wonderful free scanning apps. And then you will have to save your scan as a PDF before uploading it. So I'll work out all the details once I figure out how or if I can use Proctorio. But if I can't use Proctorio, then I'm just going to watch you myself like I am now. But either way, you got to have video in order to take the test on Wednesday. I did have an alternate plan, which was to let some people go take their test at the Makeup Center in person, but now you guys aren't allowed on campus. So there's no way for me to allow you to come to campus to take your test. The only way we can do it is online. So I'm sorry. It's just a drag for all of us. I want to remind you, you have a homework assignment or a couple of short assignments due tonight. That material is part of your test on Wednesday, so hopefully you've gotten it done or most of it done. But we can talk about that homework today before we end class if people still have questions. All right, so what are we gonna do today? Today, this material is not on your test on Wednesday. So this is material that you have homework on for Thursday. So after the test, you can do homework on this, but don't worry about it for Wednesday. Okay, so what we're gonna do is we're gonna do word problems. So we're gonna do problems on rates of change in applications. So we're gonna do some physics problems, some biology, business, economics. We might have a couple of business majors in the class. I think I have a chemistry example, but there might be a chemistry problem in your homework. And then other sciences, social sciences, etc. So I have a few examples. We've actually got a worksheet. I forgot to mention, there's a worksheet. There's 2 worksheets on Canvas, and if you didn't download them and print them out, that's okay. You can pull them up on Canvas and just write down the problems. And I'll also show the problems on the screen. Let me make sure I don't have anybody trying to get my attention. No, okay. All right, so let's get going. So we're gonna start with this example. So some of you might have the worksheet already printed out, or you can write this down. So this example says a particle moves along a straight line. Its position function is given by, and it's a cubic polynomial. S of t is 2t cubed minus 21t squared plus 60t plus 12. And t is greater than or equal to 0 in seconds, and s is in meters. So this particle is moving along a straight line, and it might be going back and forth, but it's not going, on a curved path, and it's not going up and down. It's just moving along a straight line, back and forth possibly. So part A says find functions for its velocity and acceleration at time t. So we've looked at velocity before. In fact, that's sort of the whole point of doing calculus. So v of t is always the first derivative of the position function, s prime of t. So for this one, I'm going to differentiate with respect to t. So I get 6t squared minus 42t plus 60. So that is the velocity function as a function of time. So what about acceleration? So acceleration is always the second derivative. So the acceleration is the rate of change of the rate of change of the position of the particle. Hang on, I'm getting a bunch of notifications I have to turn off. I forgot to do not disturb. All right. All right, so acceleration is going to be the derivative, the second derivative of the position, or the first derivative of the velocity. So differentiating the velocity, I get 12t minus 42. And that's the acceleration at time t. All right. Part B. Part B says draw a diagram showing the motion of the particle along the line. So this is the sort of complicated part. What we're going to do is we're going to have a straight line, and we're going to show the path of the particle as time progresses. So we're going to use an arrow, and we might go to the right, turn around, go to the left, and then turn around again, go to the right. So we're going to draw the path above the straight line just to illustrate the turning points and which direction the particle is going. So in order to get all the information we need to get this path, we're going to have to do some more work. So we're going to have to figure out when is it moving forward, and forward is the positive direction on the line, so that would be to the right. We're going to have to see when is the velocity function positive, when is it greater than 0. That tells us it's moving in the positive direction. And backwards, it's moving backwards when the velocity function is negative. So v of t is going to be negative when it's moving backwards. Backwards is to the left. All right, and it changes direction when, well, sometimes when v of t is 0. So sometimes it can just stop and not change direction, and sometimes it stops instantaneously and changes direction. So when we find all the times that the velocity is 0, we might be finding it might mean it's changing direction there, but not always. The velocity can be 0 and still it's moving in the same direction. It might not change direction. But that's a good way to figure out when it's changing direction. So let's take the velocity function, 6t squared minus 42t plus 60, and we set it equal to 0, and we solve. So I factored out a 6 from everything, and then I'm going to factor. So this is what I get. I get 6 times t minus 2 times t minus 5 equals 0. And so from that, we can see what times t this thing is stopping. Not necessarily whether it might not be moving or changing direction at those times, but at least we can see where it stops and where it might be changing direction. So we get t equals 2 seconds and t equals 5 seconds. Those are the 2 times when it stops kind of momentarily and might be changing direction. Let me just make sure nobody's trying to get into class because we're missing a couple of people. All right, nobody's in the waiting room. All right. So now what we're going to do is a sign diagram. A sign diagram, this is not the path of the particle. This is simply a diagram telling us the sign of the velocity function, okay? So it's not the path of the particle. So this is a number line for time, t, and I'm going to mark off the number line at 2 seconds and 5 seconds. And so now we're going to put a plus sign or a minus sign where the velocity is positive or negative, okay? So first of all, let's see. So yeah, I'm going to use the factors in the polynomial for the velocity function. So there's somebody who's not muted. Let me see. Okay. Okay, Kaleo, I'm muting you. Because I can hear you moving around. It's distracting. Okay, everybody's muted now. So now and above the number line, I'm going to look at the sign of each factor, t minus 2 and t minus 5. Under the number line, I'm going to look at this whole polynomial, the sign of the polynomial v of t. So first of all, at those points, t equals 0, t equals 2, and t equals 5, what is the velocity? So the velocity at time 0, if we plug 0 in for t into the velocity function, 6t squared minus 42t plus 60, we do get positive 60. So the velocity is, oh, sorry, I'm putting my zeros for the other two numbers. So the velocity is positive when time is 0. The velocity is 0 when t equals 2 seconds, and the velocity is 0 when t equals 5 seconds. Okay, so I'm just putting zeros where I know it's 0 and a plus sign where I know it's positive. Now, to get the sign of the velocity in between 0 and 2 seconds, all I have to do is pick one number in that interval, plug it in, and if it's positive there, then it's positive at all numbers between 0 and 2 seconds. And then I do the same thing between 2 seconds and 5 seconds. Just pick one number in that interval, and if it's positive at that number, it's positive at all the numbers in that interval. And why is that? How do we know that? Well, the velocity is a polynomial. It's a continuous function. So there's no way that it can change sign in that interval, like between 0 and 2. It can't be positive at one number and negative at another number, because then it would have to be 0 somewhere else. And we know where it's equal to 0. It's not going to be equal to 0 anywhere between 0 and 2. So if it's positive for one number, it's going to be positive for all numbers in that interval. That's the nice thing about continuity. So I pick a number between 0 and 2. Let's say I pick 1. If I plug it into t minus 2, so 1 minus 2 is negative, and plug it into t minus 5, so 1 minus 5 is also negative, and I know negative times negative is positive, so it's positive. So the velocity function is positive on that interval, okay? So I'm plugging the number into each of the factors, and then I multiply those together, and I can tell the sign of the whole velocity function. So now the interval from 2 to 5, I pick some number, let's say 3, plug it into t minus 2, I get 3 minus 2, which is positive. Then plug it into t minus 5, I get 3 minus 5 is negative. Positive times negative is negative. So the velocity is negative between 2 seconds and 5 seconds. Now, after 5 seconds, pick a number. I say 6. You can pick anything greater than 5. Plug it into t minus 2. I get 6 minus 2, which is positive. Then 6 minus 5 is also positive. Positive times positive is positive. So the velocity is positive after 5 seconds. So we now know the direction that it's moving at all times greater than or equal to 0. So between 0 seconds and 2 seconds, the velocity is positive, so that particle is moving forward or to the right. Between 2 seconds and 5 seconds, the velocity is negative, so the particle is moving backward to the left. All right, and then when t is greater than 5, it's positive again, so it's moving forward. All right, so that's a sign diagram. We still don't have the path of the particle. We still haven't done the picture of the motion. So I'm going to change slides, but I can tell some people are still writing, so I'm going to pause for a second. Oh, there's somebody named Plippy Ploppy in the waiting room, and I'm not going to let that person in because they're not using their actual name, unfortunately. There's no way to send them a message. Interesting. Okay. All right, let's see. Okay, changing slides. So now we're going to try to analyze or describe and then draw a picture of the motion of the particle. So let's find where the particle is. Its distance from zero. What are our units? Sorry, I have to go back. I can't. Oh, meters, right. So we want to know where the particle is at all these points in time so we can draw the path, right? We know time intervals when it's going forward and backward, but where exactly is it at those times? So we're going to plug in some numbers into the position function to get its position at those times. So I'm going to plug in the important points at time 0 when it first starts. Where is it? It might not be at 0, at position 0 meters. And then we're going to plug in 2. Where is it 2 seconds later? And where is it at t = 5 seconds? So we can draw the picture. So plugging in 0, I get just 12 meters. If I plug in 0 into that position function, right? 2 times 0 cubed minus 21 times 0 squared plus 60 times 0 plus 12. We just get 12 meters. So it's not starting at the origin. It's not starting at 0 meters. It's starting at 12 meters. And where is it 2 seconds later? If we plug in 2, s of 2, we get 2 times t cubed minus 21 2 squared plus 60 times 2 plus 12. So if I do my arithmetic correctly, I get 64. 2 times 8 is 16 minus, yeah. So it's moved from 12 meters up to the, it's going to the right, it's going the positive direction, and at 2 seconds, it's at 64 meters. And we know it turns around again, right? Or it turns around at that time. So where is it at t = 5 seconds? We got to plug in 5. So s of 5 is 2 times 5 to the third minus 21 5 squared plus 60 times 5 plus 12. And if I did that correctly, I got 37 meters. So it's moved from 12 meters to 64 meters, then it's turned around and gone backward, and it's at 37 meters. And we know that at 5 seconds, it turns around again and it goes forward. So this is going to be the picture of the path. So here's the line that the particle is traveling on, right? It's on this line. It's moving back and forward on this line. So I'm going to mark off the important points. So there's 0 meters, 12 meters. So it starts out at 12 meters. It moves to the right. So it starts out at t = 0 at 12 meters. So I've written the position in blue, and the time that it's at that position is in red. Okay, at time 0 seconds, when it first starts, it's 12 meters from the origin. And it travels to the right for 2 seconds. So 2 seconds later, it's at 64 meters to the right of the origin. So the path is going to be, I'm drawing the path above the actual line just so I can show which direction it's moving and when it turns around. So now we know it turns around at 2 seconds. It moves to the left for 3 more seconds. And at t equals 5 seconds, it's located 37 meters from the origin, to the right of the origin. And then we know at that point, it turns around again and starts moving to the right. And it stays moving to the right after that forever. So that's what it looks like. So the arrow at the end just shows that it's going to the right indefinitely. It's never going to turn around again. So that's how we draw the path and the motion of a particle traveling on a straight line. So I'm going to let somebody else in. Hi, Augustine. Welcome. I need your video on. Augustine, if you don't have video, you can't take the test on Wednesday. So you have to figure that out, and I have to be able to hear you. So you have to have audio and video by Wednesday. I can't see you, I can't hear you, and that's not going to work. All right, let's get back to this problem. So part C says, when is the particle slowing down? So this is a really important concept, slowing down and speeding up. So we have to look at not just the acceleration, but also what direction the particle is moving at that time. So if the particle is moving forward, if it's moving in the positive direction, in order to be speeding up, the acceleration has to also be in the positive direction, right? So imagine you're driving a car and you're going forward. If you hit the gas, your acceleration is in the positive direction, so you're going to speed up. But if you hit the brakes, your acceleration is in the negative direction, you're going to slow down, right? The point is that the directions are opposite when you're slowing down. The directions have the same sign when you're speeding up. So if you're going in reverse, it doesn't really work this way with a car, but if you're going in the negative direction, if your velocity is negative, then speeding up means that your acceleration is pushing you in that direction. So your acceleration is also negative. If you're traveling in the negative direction, but your acceleration is in the opposite direction, your acceleration is positive, you're slowing down. So the point is that you're only slowing down if the velocity function and the acceleration function have opposite signs, okay? Slowing down, they have to have opposite signs. Some students think slowing down just means acceleration is negative, but that's not true. Imagine a falling object, right? There's acceleration due to gravity. The velocity is negative because it's falling. Gravity is accelerating. Acceleration due to gravity is also negative. It's making it speed up. So velocity is negative and acceleration is negative. It's speeding up. The velocity is becoming more negative, right? So you have to remember, they have to have the same sign to be speeding up. Opposite signs if they're slowing down. So speeding up, the velocity function and the acceleration function have the same sign. So this is critical. So I'm going to have to change slides, and so I'm going to pause for a moment. I'm looking at. Hi, Augustine. I can see you now. All right. So let's figure out where it's speeding up and where it's slowing down. So let's look at the sign of the acceleration function. So again, acceleration function for this particle is 12t minus 42. So to figure out its sign, let's figure out where it's equal to 0 and find if it changes sign at 0, if it's positive on one side and negative on the other. So if I set it equal to 0, I get 6 times 2t minus 7 equals 0. So the acceleration is negative at 7/2 seconds, or 3.5 seconds. That's just where the, not negative, did I say negative? Sorry, the acceleration is 0 at 3.5 seconds. So I'm just making another number line for the time because I want to compare the sign of the velocity with the sign of the acceleration. So the velocity, we already know, is positive from 0 to 2 seconds, and it's negative from 2 seconds to 5 seconds, and it's positive after 5 seconds. We already know that. So now let's look at acceleration. We know acceleration might change sign at 3.5 seconds. So I'm adding 3.5 seconds to my timeline. So before 3.5 seconds, between 0 seconds and 3.5 seconds, I just plug in a number and see what the sign of the acceleration function is. So if I plug in, say, 2, which is between 0 and 3.5, I get 6 times 4 minus 7. I get 6 times -3. I get something negative. Okay, so the acceleration is negative all the way from 0 seconds to 3.5 seconds. So we know the acceleration is 0 at 3.5 seconds. So let's see if it's positive after 3.5 seconds, or it might still be negative. We don't know. So I'm going to plug in some number greater than 3.5, let's say 4, into the acceleration function. I get 6 times 2 times 4 minus 7. So 2 times 4 is 8, minus 7 is 1. So 6 times 1 is a positive number. So, oops, so I'm putting plus signs after, after 3.5 seconds. So the acceleration is positive when time is greater than 3.5 seconds. So acceleration is negative. It's not moving backwards, but its acceleration is in the negative direction from t equals 0 to t equals 3.5. Then the acceleration changes direction, and the acceleration is in the positive direction after 3.5 seconds. That doesn't mean it's moving in the positive direction. It means that something's pushing it in the positive direction. It might be moving backwards and be pushing, and something is pushing it positive. So now we look at the signs of acceleration and velocity on these time intervals. So where is it slowing down? It's slowing down where the velocity function and acceleration function have opposite signs. So we have to look at that timeline and find the intervals where one of them is positive and the other is negative. It doesn't matter which one. So it's slowing down where they have opposite signs. So it looks like we are slowing down when between the time that it starts moving and 2 seconds later. So for the first 2 seconds, it's moving in the positive direction, but its acceleration is pushing it somehow in the negative direction. The velocity is positive, but the acceleration is negative, so it's slowing down. It's moving in the positive direction, but it's slowing down. Also, it's slowing down between 3.5 seconds and 5 seconds, because there its velocity is negative. It's actually moving in the negative direction, but the acceleration, something is pushing it in the positive direction. So it's moving this way, but something's pushing it that way. So the direction is negative, but the acceleration is positive. So it's slowing down. Then where is it speeding up? So it's speeding up where the velocity and the acceleration have the same sign. So where's that? Well, it looks like acceleration is negative and velocity is negative between 2 seconds and 3.5 seconds. So the particle is speeding up where they're both negative, acceleration is negative and velocity is negative, and that's between 2 seconds and 3.5 seconds. And then it happens again when they're both positive. So after 5 seconds, the particle's moving in the positive direction and something's pushing it in that direction. So it's speeding up. The velocity is becoming more positive. So when t is greater than 5 seconds. So there's 2 intervals where it's slowing down, and it's moving in the positive direction but slowing down. That's from 0 to 2 seconds and 3.5 to 5 seconds. It's moving in the positive direction, it might be moving in the positive direction but being pushed in the negative direction, or it might be moving in the negative direction and pushed in the positive direction. And then it's speeding up when both have the same sign. So it could be moving in the positive direction and being pushed in the positive direction, or it could be moving in the negative direction and something's pushing it that way as well. So as long as they have the same sign, it's speeding up. All right. Oh, I see Stefan, so sorry. Let me unmute you, Stefan. Let me find you and hang on a sec. Stefan, what's your question?
So why is 0 not included on the interval where it's slowing down?
Oh, and that is a great question. So the velocity is positive. If we let's plug 0 into the acceleration. So if we plug 0 into the acceleration, we do get negative, right? So you're absolutely right that it is slowing down at t equals 0. So let's go back. So everyone go back to the answer for slowing down. Stefan corrected me. I forgot to test t equals 0 for the acceleration. I did test it for velocity. I found that the velocity is positive when time begins. It's already moving in the positive direction, but I forgot to check its acceleration at that time. Acceleration is in the negative direction when time is 0, so they have opposite sign, so I should have included t equals 0 in that interval. So that's right here. I added, so I did say 0 less than t less than 2, but I should have said 0 is less than or equal to t, and t is less than 2. Thank you, Stefan. Sorry I didn't notice you had your hand up, so sorry. Is that good?
Yes.
You're good. I'm gonna mute you now. Sorry. Thank you. So yeah, if you guys have a question, please chat with me, and I'm gonna try to keep an eye on the chat window. Anyone else have a question? Just tell me in the chat and I'll unmute you. All right, let's keep moving. So, all right, let's look at problem 2. If you don't have the worksheet handy, if you didn't print it out, that's okay. You're just gonna have to write this down. So problem 2 says a bacteria culture starts with 500 cells and it doubles in size every hour. So that means the number of cells doubles every hour. So in part A, we're going to have to find a function that represents the size of the culture at any time t. So it's going to be a function of t, and it's going to represent the size, the number of cells in this bacteria culture at that time. So if you don't have the worksheet, just write that down. All right. So we're going to have to start by, first we're going to name the function. I'm going to call it P for population. So P of t is the population of this culture at time t. Population just means number of cells. And so I'm going to plug in a couple of times and see if I can find a pattern. So I'm not plug in because there's nothing to plug it into, right? I'm going to find the number of cells at certain times and then look for a pattern. So when t is 0, so when time first begins, we've got 500 cells. That's our initial population. So P of 0 is just 500 cells. So what happens an hour later? So an hour later, it says that it doubles in size every hour. So an hour later, we have 500 cells times 2. We multiply it by 2. So I'm just going to leave it as 5 times 2. I'm not going to write it as 1,000 because I'm looking for a pattern. So when you look for patterns, try to keep things sort of factored. Don't multiply things out because you're looking for patterns, and it might help to just leave it written like this. So 2 times 500 is P of 1. Then an hour after that, it doubles again. So P of 2, which means the population at time 2 hours. Well, we take the population that we had an hour earlier, that was 2 times 500, and we double that. So I multiply that previous population by 2. And leave it like that because you're looking for a pattern. So then let another hour pass, and P of 3 hours, the population 3 hours from when it started, we take the previous population an hour earlier, and that looked like this, 500 times 2 times 2, and we multiply that by 2. We have to double it again. So we've doubled it each hour. So now we have 4 populations, right? The initial population, 500. The population 1 hour later, which is 500 times 2. And the population 2 hours later is 500 times 2 times 2. And 3 hours later, it's 500 times 2 times 2 times 2. So that's 3 hours after time has begun. So the pattern should be clear, right? So we can write that now in terms of t. So P of 0 is 500 times 2 to the 0, because 2 to the 0 is 1. P of 1 is 500 times 2 to the 1, because it's 500 times 2. Then P of 2 is 500 times 2 squared, because there's 2 times 2. And then the last one we have is P of 3, which is 500 times 2 to the 3. So P of 3 is 500 times 2 to the 3. P of 2 is 500 times 2 to the 2. P of 1 is 500 times 2 to the 1. And P of 0 is 500 times 2 to the 0. So we can say that P of any t, the population at any time t, is going to be 500 times 2 to the t, whatever t is. So if we want to know the population 24 hours later, we just plug in 24 for t into 500 times 2 to the t. So that's our population function. That's an exponential function. It's doubling every hour. It's an increasing function. All right, any questions on part A? Okay. So let's see. Part B says find the rate of growth after 6 hours. Rate of growth just means rate of change, but we want to get the rate of change after 6 hours, not at any time t, but after 6 hours. So the rate of growth is just the derivative with respect to time. So dp dt. So I'm going to differentiate the function that we got in part A. So remember, that's an exponential function. That is not a power function. I cannot bring down the exponent and reduce the exponent by 1. I have to use the formula that we learned and hopefully have memorized for the derivative of an exponential function. So we just bring the constant stays the same because we can use the constant multiple rule. We differentiate the 2 to the t. The derivative is 2 to the t times the natural log of 2. That's the derivative of the exponential function 2 to the t. It's always going to be 2 to the t times and the natural log of 2. So remember, the formula for the derivative, so let me write it up here. The formula for the derivative of any exponential function, any base, is always going to be b to the t times natural log of b. We got to remember that. All right. So in part B, we wanted the rate of growth after 6 hours. So now let's just plug in 6. And after 6 hours, we're going to plug in 6. So I'm going to take p dt evaluated at t equals 6. So that just means plug in. So we get 500 times 2 to the 6 times natural log of 2. And now in word problems, we do want to put it in a calculator. I recommend using a memory button, a memory function, or actually you don't have to, there aren't that many operations. Put in 2, take the natural log of that number, don't write it down, you're gonna get a long decimal, but the calculator remembers more decimal places than it actually shows you. So find the natural log of 2, then multiply that by 2 to the 6th, and 2 to the 6th is 64. And then multiply that number by 500. And then how do we round this? Well, it's a bacteria culture. We cannot have a fraction of a cell, right? So if you have people, bacteria, cells, cars, anything that can't be chopped up, right? People, cells, cars can't be chopped up. You have to round it to the nearest whole number. And I always say round down. Like if you have 0.7, well, that's not quite a whole person or bacteria cell, so just round down. But round to the nearest whole number is good enough for me, I guess. So rounding to the nearest whole number, so I got 22,180 cells per hour. So don't forget your units. You have to have units, and it's a rate of change. So it's going to be cells per hour, 22,180 cells per hour. That's the rate of growth after 6 hours. Any questions on this one? All right. So if you have a question, try to get my attention in the chat. All right. Let's see, where are we? All right, let's do another example. So we did a physics example, we did a biology example. So let's look at an economics or business example. So I'm gonna give you guys a definition. You may have heard of this before. So suppose that we have a cost function. So C, for cost, C of X is the cost of producing X items. So you own a factory and it makes television sets. The cost of making X television sets is your cost function. Now, the marginal cost is the first derivative of the cost function, C prime of X. And that's the rate of change of the cost when X items have already been produced. Okay, so the rate of change isn't constant. The rate of change of your cost is not constant. Okay, your cost isn't constant, and the rate of change of the cost isn't constant. And so, so you need to understand your functions in order to figure out and optimize your profit or whatever. Make sure you're maximizing your cost. You don't want to make too many items too quickly. You might be spending way more money than you want to spend. All right, so that's the definition. So now we're going to do an example that I think is on, yeah, it's on the worksheet. Okay. All right, so I'm going to change slides and move on to the worksheet problem. So number 3 on our worksheet says, suppose that the cost in dollars for a company to produce X pairs of a new line of jeans is this function. It's a cubic polynomial. 2,000 plus 3x plus 0.01x squared plus 0.0002 x cubed. And then it says find and interpret C prime of 100. So first of all, let's look at this function. So this function, it's just a polynomial, right? What if, just for an example, what if we plugged in 0? So let's just kind of figure out what's going on here. What is C of 0? Oops. C of 0, if we plug in 0, notice that all the terms that have an x in them, those are all 0. So C of 0 is $2,000. Now, what does that mean? That means if you don't produce any genes, you've spent $2,000. So we have to think about that realistically. Why would it cost us $2,000 to make nothing? Well, that's probably your overhead. Your overhead is, your rent, your utility bills, maybe the people that you paid to come to work that day. They haven't done anything yet, but you had to pay them to come to work. So it'll cost you, if you don't make any genes, it's still going to cost you money, right? So your job is to optimize your profit, right? So to sort of minimize your cost while maximizing your revenue and finding this balance and making sure that you're making as much money, your profit is maximized when you have this balance between cost and actual money coming in, revenue. So, all right, so let's look at the question. Find and then interpret C prime of 100. So differentiating that function is not too hard. It's called the marginal cost function. And it's just a polynomial. So we're going to get 3 plus 0.2x plus 0.0006x squared. So that's our marginal cost function. So now the question asks, what's C prime of 100? So the marginal cost at 100 is, plug it in. So 3 plus 0.02 times 100 plus 0.006 times 100 squared. I get 11. $11 per pair. Don't forget your units. So that's C prime of 100. So I am going to unmute you guys because I'm tired of just hearing myself. Alex, I unmuted Alex, I think. No, Natalie, you are not unmuted. All right. Does anyone have an idea how to interpret this? You don't have to raise your hand, just say something. We can all hear you, I think. Anybody have an idea what this means? $11 a pair? What does that mean?
I think it means that when you make 100 pairs of pants, it's going to cost you $11 per pair to make 100.
Okay, say it again. When you make 100 pairs of pants, it's going to cost you $11 per pair?
Yeah. Per pair of pants at 100. If you produce less amounts, it might cost more or less, depending on how much you make.
All right. All right. So anybody have another way of saying that? I think that sounds right.
Like the 100th pair of pants is going to cost $11.
The 100th pair? Who is that? Who is that speaking? I can't see you.
Emma.
Emma, where are you? I'm trying to find your picture. Okay. So it's not the 100th pair, it's the 101st pair. So this is the approximate cost of making 1 per pair of jeans. So the 101st pair of jeans. So once you've made 100 jeans, the cost of making just one more pair. After you've made 100 pair of jeans, the cost, what it will cost you to make one more pair. So it was, I'm pretty sure Jeff was saying that. So it changes, right? Depending on how many pairs of jeans you've already made, the cost of making one more after that is different. And that's what they call the marginal cost. Jeff, are you a business or econ major?
No, I'm a computer science major, but that's not what I was saying at all, actually. I actually forgot what marginal cost, I forgot how it worked, but I recall the how marginal cost works now, so I'm fine with that.
Okay, it sounded close to what you were saying. Okay. Do we have any business majors or econ majors here? Anybody? I guess you guys are mostly computer science and engineering, but econ is a very mathematical subject. All right, I'm gonna put you guys on mute again. I think. All right. Well, I guess I gotta mute you one by one. Oh, here we go. No. All right, I'm trying to mute you guys again one by one. Well, that's not working. All right. I'm not able to mute some of you, but I'll try again later. There we go. Somebody's muting. All right. Okay. Let's keep moving. Oh, so now I think that's it for my slides. So now there's another worksheet. Oh, I see. Okay, hang on a sec. I'm having a little technical. All right, I think I've muted most of you. All right, so now there's another worksheet. If you haven't got it, I'll show you. Let me open up the worksheet for those of you who haven't downloaded it or can't download it for some reason. And then I'll share that with you. Although that's not the right thing. There it is. So I think I've just shared my worksheet. All right. So it says rates of change in the natural and social sciences. Can everyone see it? Give me a thumbs up if you can see it. Okay, good. All right. All right. So you can download the worksheet. So what I'm going to do, or what I did, and I sent you a message, but it was really late last night or early this morning. So to come to class, if I were you, I would go to the calendar in Canvas and just click on the class that's in the calendar, and you'll have the meeting link to come to the Zoom meeting, and you'll have whatever worksheets I've prepared for that day. So that'll all be in the calendar event. It's also hopefully going to be in the module for that week, but I'm definitely going to have it in one of those two places, if not both. Okay. So you can hopefully get these worksheets before coming to class. but I'm kind of doing this on the fly every day, and I might not get together, I might not have it all together before class. You might have to wait till we actually meet to download the worksheets. All right, so the first problem on this worksheet is about a ball being thrown upward. Let me see what time it is. Wow, it's 10 o'clock. So let's see, it's time actually for a 10-minute break. So I think we should all take a 10-minute break right now. And I want to do probably one of these problems when we come back and then discuss the test, okay? I don't think we're going to do all of these worksheet problems, but we definitely need a 10-minute break, and we definitely need to talk about the exam. So I'm going to mute my video, I think, if I can, for about 10 minutes, and then we'll all come back in 10 minutes. So let's come back at 9:56. Let's come back at 6 minutes after 10 o'clock. 7 minutes after 10 o'clock. All right? I'll see you in 10 minutes. All right, I'm back. I hope you guys can hear me. And you can see my worksheet. So if you weren't able to print it out, if it's possible, open it up on another window on your computer so you can keep it open, or you're going to have to copy down from what I'm showing you. So there's problem 1, part A through E, and then problem 2, which is got more parts. It's quite long. It's more a little similar to the example I did during lecture, but it's a more complicated function. So I think what I want to do is see how long it takes people to do problem number 1. So what I want you guys to do is work on problem number 1, and I am going to try something. I am going to shoot, where is it? Let's see. I wanted to put you guys into groups. Let's see if I can do that from here. I think I should have, I thought I set that up. Shoot, where is it? I'm going to stop sharing for a moment to see if my controls. Oh yeah, okay, so I had to stop sharing because I couldn't see all my controls. So what I'm going to do, and this is sort of an experiment, you guys, I'm going to put you into groups of 3. There might be one group of 4 because we have, I see 19, no, we have 18 participants besides me. Okay, so I'm putting you into breakout rooms. So you're just going to be with 3 people, and I don't know who you're going to be with because I'm having Zoom do this automatically. So I'm creating breakout rooms. And you are, let's see. I'm just looking at my options. You guys are being moved automatically into a breakout. Yeah, into a breakout room. Okay, here we go. See what happens. So all of you are being invited to join a breakout room. So go ahead and accept the invitation. Good job, you guys. Awesome. Oh, there's only 3 breakout rooms. Sorry, I did it wrong. I meant to do 3 people per room. Well, why don't we leave it like this and see how it works? So you guys are in breakout rooms with 6 people. I meant to do 3, but let's see how it works. So you can talk to each other, unmute yourselves. If you're not able to unmute yourselves, let me know, because I think I'm gonna I'm unmuting you. Okay, so hopefully you can hear each other and you can compare answers and talk to each other. If you're having trouble, send me a chat and I'll see what I can do.
Doing number 1.
Okay. Well, you guys, I'm just checking in. I'm gonna check each group and see how you're doing. Is everyone okay here?
Yeah, we're doing good.
Yes.
Fabulous. I'll see you in a few minutes. I'm gonna give you like a 60-second warning to come back together. I'm not sure how that works, but I'll try it. But I'll leave you right now and go visit another group.
Okay.
Hi, breakout group 2. How are you guys? Is everyone all right? Oh, you're not unmuted. Let me unmute you. Can you, hang on. Can you guys hear each other?
I can hear Caesar.
You can hear Caesar? Hallie, are you not able to hear anybody? Or
I can hear people.
you guys are okay? You can
Yeah.
okay, unmute yourselves if you need to talk. Any questions for me right now? All right, you guys, I'm gonna go visit the other groups and see how they're doing. Hi, group 3, I'm just checking on you. Are you guys okay on that worksheet? Does anyone have a question? I'm gonna So if anyone has a question, I think you can unmute yourselves. Stefan, I see you're unmuted. Do you have any questions?
No, I was just staying generally open to the room.
Okay, so you guys compare answers, ask each other questions. I'm circulating with the groups and checking in, and I'm gonna give you guys like a 60-second warning when it's time to come back, and hopefully that'll work. I've never done this before, but I'll leave you be for the next couple of minutes, and then I'll check in on everyone again. All right, see you soon. Oops. All right, you guys, I think everyone is back. I think everyone's back. So, how did the worksheet go? Does anyone have a question? I think you guys need to be, hang on, unmuted. Let's see. Anyone have a question? I'm going to go through these with you, but I want to see if anyone got stuck anywhere or confused. Anyone have a question about this worksheet? Problem number 1. You guys are all okay? All right, so let me see. I'm going to share my screen. And I might call on you. So I've got everyone unmuted. Can everyone see my screen? I've got my worksheet. All right. So the ball is thrown upward with a velocity of 8 per second, and the height after 2 seconds is given by this function. So the velocity after 2 seconds is fairly straightforward. You differentiate that position function, right? So Cameron, are you there? Where are you, Cameron? I can't see you.
Yeah.
I think you are. What did you get for the derivative?
I got 80 minus 32t.
80 minus I got. Okay, great. And then, did you plug in anything to get the velocity after 2 seconds, Cameron?
I got 16.
What did you plug in? 2? Yeah. That's what I got too. 16 feet per second. Don't forget your units. Velocity has unit. All right. Let's see. Hallie, did you do part B?
No, I didn't get that far.
Oh, okay. How about Nicholas? Did you do part B?
Yeah, I did part B.
Okay, how did you do it? It says, what is the maximum height reached by the ball? So how did you figure out maximum height?
So we take velocity equals 0. I just plug in that v equals to 0.
Okay, so why would the velocity be 0 when it reaches its maximum height? Why did you do that?
Because when it reaches to its maximum height, it's gonna change its direction.
Perfect.
So, which means that velocity is 0.
Okay.
Equals 0.
Right. Yeah. When it gets up to the top, it has to turn around. So like instantaneously, the velocity is 0. So, oops. Oh, sorry, I didn't finish part A. So part A, look at what I did. So part A, we also had to find the velocity. Sorry, go back to part A, you guys. I forgot. We were finding the velocity after 2 seconds and 4 seconds. And so I didn't discuss 4 seconds. Sorry. So if we look at part A again, we see that the velocity after 2 seconds is positive. It's 16 feet per second. But after 4 seconds, it's negative 48 feet per second. So it's on its way down already. I forgot to go through that with you guys. Anyway, so let's go back to part B. If we set, it turns around. So if we set the velocity equal to 0 and solve that, hopefully, this is my algebra. I divide everything by 16. Makes it easier for me to solve. I got 5/2 seconds. Is that what you got, Nicholas?
Yes. Yes, that's what I got.
Perfect. So, so maximum height. So I forgot. It's not always gonna work. So you do set your velocity equal to 0, but sometimes, and in this case, we know it's gonna come back down. But sometimes you have something that's always moving in one direction, and it does have 0 velocity at some point, but that doesn't mean it had to turn around. So what you guys need to remember to do is check. So I'm going to check the direction of the object just to make sure it did turn around there. So we set it equal to 0, but that's not always going to give us the answer. So sometimes we just stop and we don't turn around. So when we check the answer, we find where or when it's 0, then we make a sign diagram. We have to do a sign diagram and test. Is it changing direction at that time? So I know that the velocity is 0 at 5/2 seconds. So I'm going to plug in something between 0 and 5/2. So maybe plug in 1. So you get 80 minus 32, which is a positive number. So the velocity is positive on that interval. But then plug in something after 5/2. I plugged in, I think, 3, and I got a negative number, so the velocity is negative there. So if you don't do this part, you won't get full credit, because there are definitely situations where the object has stopped but has not changed directions. So you can't assume it has changed directions. So you have to do a sign diagram. So we do see it is going up, and then it's coming down. We had to check, sure. With a ball, it's just intuitive that when it stopped, it probably turned around. But with most actual physical situations, there will be times when it stops but doesn't turn around. All right. So I just want to emphasize that we need to test that point. All right. So now that means it did reach its maximum height at 5/2 seconds. So now we have to actually, the question says, what is the maximum height? So now we have to go back to the position function or the height function, and we have to plug that time in. So don't forget that. The question did not ask, when does it reach its maximum height? The question asked, what is the maximum height? So we figured out it's gonna turn around after 2.5 seconds, but now we have to figure out how high is it when that happens. So plug in 5/2 into the height function. You get 80 times 5/2 minus 16 times 5/2 squared. And I got 200 minus 100. I got 100 feet. Is that what you got, Nicholas? 100 feet?
Yes.
Okay.
Yes, that's what I got.
All right, that was the maximum height of the ball, 100 feet. All right. So, who do we have here? Tai Chi, how are you? Tai Chi?
Yeah.
Hi. Did you do part C?
Oh, I didn't solve that.
You didn't solve part C? Okay.
Yeah.
Okay. I can bug somebody else. Hang on. Let me see who else I have. How about you, Emma? I'm going to unmute you, Emma. So, oops. There you go. Emma, did you do part C?
I did.
Okay. How did you do it? It says, what is the velocity of the ball when it's 96 feet above the ground on its way up and on its way down? So just tell us how you approach this problem.
So I set the original position equation equal to 96 feet, and then solve for t. So solve for when it's going to be 96 feet, and then got the 2 times when it's going to be, and then put it in the derivative to find the velocities.
Perfect. That's great. That's exactly what everyone should do. So figure out the time that when it's going to be 96 feet above the ground, and then plug the times, you'll get 2 of them, into the velocity function. So set the height function equal to 96. So find out how long it takes for s of t to be 96. So I'm setting the original height function equal to 96. Get everything on one side. Then solve this equation. I like to divide everything by 16. So I get t squared minus 5t plus 6. Then I can factor t minus 2 times t minus 3. And so I got 2 seconds and 3 seconds. Emma, is that what you got for the times? 2 and 3. So t equals 2 seconds. So on its way up, after 2 seconds, it's on its way up, and it's 96 feet above the ground. And let me just draw a picture of this. So here's the ground. Here's the ball going up. Here's the height, 96. So it goes through that height at 2 seconds, and then it comes back down. And at 3 seconds, it's 96 feet above the ground again. So going up, coming back down. 96 is just 4 feet before its maximum height. The maximum height was 100 feet. That's 100 right there. All right. Let me make room. So now we want to find the velocity at these 2 times. So on its way up, you plug in 2 seconds into the velocity function, not the height function. So the velocity function was 80 minus 32t. Plug 2 in, and you should get 16 feet per second. Oh yeah, we already found that in part A. So we did that in part A, actually. And then on its way down, you do v of 3. And you should get negative 16 feet per second. Did I do that right? Is that what you got, Emma? Did you get negative 16 for the second one?
Yep.
Okay, fabulous. So those are the 2 velocities. On its way up, it's going positive 16 feet per second at the very moment that it's 96 feet above the ground. And then it turns around, and when it's 96 feet above the ground on its way down, it's going negative 16 feet per second. All right. So when does it hit the ground? So Richard, did you do part D? Richard? Richard? Are you, Richard, can you hear me, Richard? Where did he go? All right, let's call on Luis. How about you? I'm going to unmute you. Did you do part D? Wait, hang on, I can't hear you. For some reason. There you go. So did you do part D?
No, I didn't. Sorry.
Oh, that's okay. Did anyone just put your hand up if you got that far? A couple people, a few people, somebody I haven't heard from. See how? how did you do part D? When does the ball hit the ground? How did you solve that?
Take the s function equals to 0.
Right, it hits the ground, the height off the ground has to be 0. Good. So we set the position or the height function equal to 0. So 80t minus 16t squared is equal to 0. I factored out a 16t. I have 16t times 5 minus t. And I have, there are 2 times when the height is 0. 0 seconds or 5 seconds. So is the ball hitting the ground at 0 seconds?
No,
Yeah.
because it
Go
starts from the 0 seconds.
Right. When t equals 0 seconds, it's just sitting on the ground. It's not hitting the ground. So we throw that one out. So it's hitting the ground at 5 seconds, right? It's sitting on the ground at 0 seconds, and then it goes up, comes down, and hits the ground at 5 seconds. And then in part E, it says, what is the velocity when it does hit the ground? And so then you just plug 5 into the velocity function. So I'm plugging 5 into 80 minus 32t. So I get negative 80 feet per second. So that's how fast it's going. And it's negative because it's still going in the negative direction. Okay, negative 80 feet per second at the instant that it hits the ground. Okay, so let me see. I think that's it for problem 1. Yeah, so we're not going to go through problem 2. What time is it? Yeah. So what I want to do now is answer any questions about the test and possibly go through a couple of problems with you. So let me stop my share, my screen share. So does anyone have a sort of just a general question or logistical question about the test that hasn't been answered yet? And then we'll talk about specific math problems. So does anyone have a question? Let me unmute a few more people. So who's got a question about just logistically what, or technologically, what is happening with our test? Who's got a question? Emma. Emma, go ahead.
So are we printing it out and then doing it in person and then scanning it?
So I think probably not going to be able to print it out unless you have a printer right next to your computer, because I don't want you to leave my view, and the Proctorio doesn't want you to leave the camera view. So what's going to happen is I'm going to make it available to print, but I don't want anyone to get up and leave the room and go get the test off the printer. If you can sit next to the printer and it's right there, then that's fine. But what other people have done is they've just had the students, given the students a few minutes to write each question down. I would probably ask you to write each question on its own piece of paper, right? So question 1, just put that at the top of one sheet of paper. Question 2 on top of another sheet of paper. Give you a few minutes to do that. And then I would say, okay, everybody start the test, and I'm watching you. And if I'm using Proctorio, Proctorio is watching you. It's an artificially intelligent proctoring system. And then when we stop, I stop you, and then everybody is going to have a scanning app on their phone, and you're going to scan each page, put it together into a single PDF file, and then upload that to Canvas. There's going to be a submission button. Sorry, what? Somebody say something? All right, so there's going to be a submission button. We're all going to have to open up the Canvas assignment. The exam 2 is an assignment in Canvas. You open that up, and it's not there now, but there will be a submission button. And you can do it on your phone. Probably if you're taking the scan on your phone, you want to do the upload with the app on your phone. Or you can send it to yourself and then upload it using your computer. So maybe what I'm going to do is I am going to create a test. So I'm going to create an assignment on Canvas. I'm making a note to myself. And I'm going to ask everyone to take a scan of something with your phone and upload it to this assignment. It's not counted for a grade, but it's a way for us to just test out the system and see how it works. So I'll do that tonight. I'll create an assignment. I'll send you a notification, an announcement, and then you can go take a picture of a worksheet or something and upload it and see how long it takes you. Okay. You can either upload it directly from your phone into the Canvas app or send it to yourself from your phone, then upload it from your computer. Try it both ways and see what you think and see how long it takes you. So let's test it out in the next couple of days. Does that make sense, Emma?
Yeah, thank you.
Okay. And like I said, I don't know if I'm going to have Proctorio running or if I'm just going to watch you myself. So somebody at San Francisco State did this, and she didn't use Proctorio. She just watched all her students while they wrote the test, and they had to write down each question, and then she watched them as they scanned their test. I guess they had their computers open, and then they used their phones to scan, and she was watching them. And then she said it all worked fine. So we'll see. So it's been done before. And we're all just kind of trying to make things up as we go along. Any other logistical questions about the test before we talk about actual math problems? So I need you all to have preferably a computer with a camera as well as your phone. If all you've got is your phone, then you're going to have your phone on a stand so that I can watch you. And then when I give you a few minutes to scan everything, you're going to have to do it quickly. But so I'll give you a test assignment tonight that you can try it out on and see how long it takes. All right. So what I want to do now, so we have 15 minutes. I want to open up a couple of old test questions or old homework questions and see if we can, or first of all, before I do that, does anyone have a specific math question related to the test on Wednesday? Like a problem that you're working on, or you have a question about whether a certain type of problem will be on the test. Does anyone have that kind of question? Just speak up. Yes, Nicholas.
So for the Canvas questions, they say when you derive some of the inverse functions, there's like an absolute, you have to put like an absolute value for x right beside when you do the question, for example.
Not inverse sign. You're working on a problem where you have to find the derivative.
No. It's just that I already completed the assignment. It's just that the answers they show on the Newton, you have to like put a absolute value x when you derive a inverse cosecant or cosecant.
Yeah, so those I'm not going to test you on. So that's a good question. I'm glad you asked. So the only inverse trig functions that I really care about are inverse sine, inverse cosine, and inverse tangent. Okay?
Okay.
So I'm not going to give you a problem that requires the inverse secant, inverse cosecant, or inverse cotangent. Okay, the three that I care about are the first three. Thank you for asking that. I forgot. Yes, there are absolute values in the derivatives but they're not as important. They don't come up as much. And the ones that we really need are inverse sine, inverse cosine, and inverse tangent. So don't worry about that. Okay, Nicholas?
Okay.
Okay.
Yeah, okay.
Thank you for asking. Anything else like that? Anybody else have a question like that? Yes. Luis, sorry. Luis? Are you muted? Hang on. I can't hear you. Hang on. I'm unmuting you, Luis. Let me just see if I can. Okay, what's your question?
Yeah, so do we have to memorize all those derivatives? Or in sine, inverse sine? Do we have to memorize them?
I didn't quite hear you. Which ones are you talking about?
The inverse sine, inverse cosine. Do we have to memorize those derivatives?
Yes. Inverse sine, inverse cosine, and inverse tangent. Those are the three that I really care about and I can test you on. I might test you on those, yes. But don't worry about inverse secant, inverse cosecant, and inverse cotangent. Don't worry about those. Okay? Did you guys see my guide to the exam? Let me pull it up. So let me share my screen again. Let me show you what I posted in the last couple of days. Oops, there we go. So here's the Canvas course. So if you scroll down to exam 2 review stuff. So I posted an exam 2 review guide. So download this. And on the first page, this is all the derivatives that you need to know. But what I just told you was not to worry about 3 of the inverse. Hang on. So I'm having trouble. I was going to annotate this for you, but here we go. So let me show you what I want you to not worry about. So right here, don't worry about that. Oops, that's the wrong pen. So don't worry about that one. Oh no, that's not what I meant. Sorry, let me undo that. Shoot. I need to erase what I just did. Sorry, you guys, I was looking at the wrong ones. All right, try that again. I'm trying to tell you not to worry about these 2 derivatives or this derivative. Can you guys see what I just did? I hope so.
Yeah.
I hope so. So only worry about the inverse sine function, the inverse cosine function, and the inverse tangent function. The other 3 derivatives you won't need. I mean, maybe in the homework, yes, but not on a test or a quiz, because we can live without them, actually, most of the time. You might need a couple of them in Calc 2, but this semester we won't need them. All right, so download that. On the second page, let me show you. I have to, sorry, I'm having trouble with my, ooh. Sorry. There we go. So on the second page, there's the two trigonometric limits that I want you to know and know how to use. And then I gave you a long list of practice questions. There's no way anyone should do all of these questions. But look at the questions and see, make sure you know how to do them. Try a couple of them. If you have trouble, do more. Only focus on the things that you think you need practice with. I included some, sorry, I'm trying to get my highlighter. I included some review stuff. So for example, some of you need to really review your trigonometry. So that's Appendix D. These are all questions from the Stewart textbook, and I gave you a PDF of that book in our Canvas course. So we all have access to that book. It may not be legal access, but we have access. And so there are some questions on logarithms, review questions that you can do. Some of you need a little extra review on trig and natural logs and log properties. So the other thing I want you to do is whenever you're working on questions, problems, and you have trouble, you can send me a message, but it might take me a while to get back to you. I'm extremely busy with all this campus disruption. The best thing to do is go to the discussion board on Canvas and post your questions there, because there will be other students working on the same question, or maybe they want to do the problem too, and they can help you. So everyone help each other, okay? Everyone should be helping each other. Please answer each other's questions and post all your questions on the discussion board. The other reason I want you to do that is because if I answer your question, I want everyone to know the answer to that question. I don't want to just have some people have the information. I want all students to have the same information. I want to be fair. So please post all questions on the Canvas discussion board, and please go there and help other people. If I can't get to it right away, somebody else can probably help you out. And I think that's it. So there are also my old exams, but please don't just focus on my old exams, because I'm not going to give you those problems. The point of showing you my old tests was just to show you how long my tests are and what the difficulty level is generally. So when you look at my old tests, I gotta erase some stuff here. So when you look at, for example, exam 2, shoot. So there might be a couple problems here that you don't need to worry about. Let's see. Yeah, so the first problem, I've already tested you on those types of limits. So this problem is probably, it's not worth worrying about, because I've already tested you on limits at infinity. Okay? But I keep having to go back and forth. But the other ones I think are good. This one is good. The second limit, that uses those trigonometric limits that I want you to memorize. So that's a good problem to do. And practice with other problems like that. Here's a bunch of derivatives. I'll post solutions, but I want you guys to do these. Do not simplify your answers. Simply do it all in one step. Circle your answer, that's it. You shouldn't have more than one line for any of these derivative questions. There's a picture. I think we may have done one like this in class. We may have done this one in class. Maybe. Oh no, we did one like this. Oh, this is first, second, and third derivatives. So this is something everyone should be able to do, but make sure you can do it. Equation of a tangent line. You all should be able to do that. The chain rule. This is a chain rule problem number 5. We may have done one like this in class. I can't remember. It looks familiar. And then this one, don't worry about, because this is material we just covered today. So you guys won't be tested on it. So don't worry about this word problem. I don't think that's something we've, how long after it's released does it stop moving? Yeah, don't worry about the word problem on that test. I'll test you on that on exam 3 or the next quiz. I'm having trouble even. All right, and then this is really important. I will have a definition of the derivative question. This one is extremely important, number 7. This one is actually kind of hard because it has an absolute value, but try it. I'm sure you know how to do it. And then go practice more of them. You must use a limit. Or this one, you have to use more than one limit because it's an absolute value function. You really do need to do the right and left limits. So there will be definition of the derivative on your test. Does everyone, I hope everyone knows that. All right, so let me ask you guys, any last remaining questions? Just shout it out. Anybody else have a question about Wednesday? I can't hear everyone, so I'm looking for hands. I'm looking to see if anyone's waving at me. It looks like nobody's waving at me. All right, you guys. I think class went pretty well. I want to hear from you. I want you to stay in touch. Please use the discussion board for pretty much all your questions about the test. Use the discussion board, but other weird questions you can send me privately, in Canvas preferably. My email inbox is completely clogged with other email, and I would like to sort of focus on my students for the next couple days. So it's best if you send me a Canvas message because I'll definitely see that and it won't get lost. And some of you, I'm going to write to you individually because you don't have any video and you can't take the test without video. So you'll hear from me privately. All right, you guys, it's 11 o'clock and I really, really appreciate you guys doing this. You've done great work. And I wish you luck with all the rest of your classes and I hope things go smoothly for you. I'm signing off. Have a great day. All right, good night. Good afternoon.